can also look at pulse values in the AMV5000. So if we turn a pulse on, we can also look at pulse values on an AMV5000. So if we're looking at a current going from 130 to 45 amps, we've got a peak and a background time of about 150, so we're picking up a frequency of about 3.5 Hertz. If we actually look at the waveform, turn on the current, pause it, we'll see it's quite a it's got this superimposed 50 Hertz signal on it, but we've got roughly 1, 2, 3 and maybe a half cycles as we're going along. Pause it, and then if we look at it over a 2-second cycle, 2-second period, we've got 1, 2, 3, 4, 5, 6, 7. So 7 cycles, frequency of about 3.5 Hertz. Top current is 120, well, almost 130 amps, and it comes right down to, well, certainly 10 amps here on the scale, and we're picking up something a little bit lower than that, well, 5 amps on that. If you have a particularly slow pulse period, we're unable to determine the exact frequency when it gets below about 1 Hertz. So as the frequency goes down, and it's just falling now, so it's getting below the level that we can determine accurately with our frequency meter. But you can still analyze it by looking on the waveform graph. And so if we extend it out to 3 seconds, blip there. You see we've got 3 cycles roughly in 3 seconds. We're around 1 Hertz, a bit less than 1 Hertz. If we slow it down even more, we're now down at, what's that, 1.5 Hertz. Well, 1.5 cycles every 3 seconds, so about 0.7. We freeze it. It's about 0.7 or so of a hertz.